Hey, this is Josh. In this video, we're going to have a quick and thorough look to develop a Plutus smart contract. We're going to talk a bit about what a UTXO is, how the Cardano team improved upon it with the extended UTXO, and understand how we will create a smart contract with datums and redeemers. So without any delay, let's get started. Before we jump into the code, it does help to understand the theoretics a little bit. Cardano works in a UTXO model. Specifically, what it means is for every transaction, we have inputs and outputs. The inputs are the things that the transaction takes in, such as a wallet. Let's say we have a user, Bob, that wants to send money to Mary. Now, for this transaction, our input would be Bob. Bob will make a transaction, and then the output would be Mary's wallet and Bob's wallet with the remaining unspent output. UTXOs are unique in that all of the input values are spent, and then a new output of that same wallet is created to be reused. So how does this apply with smart contracts? Cardano and their extended UTXO model improves upon this by allowing the transactions to be able to carry arbitrary data instead of hash key of the inputs and outputs. So what's relevant and important to us is that, let's say we want to make a smart contract where Bob stores some ADA in the network, and then he has a secret key that he needs to give to Mary, who will redeem it. So what happens here is Bob will make a transaction. The input would be his wallet. The output would be his wallet again, and a script that contains however much Cardano that he wanted to store. Now this script will contain the password that Bob put in so that Mary can later redeem it. And we call the password the datum. Now, when Mary wants to redeem it, she would make another transaction with the script as an input and also include data to validate that she is who she should be. In our simple example, that would just be the password that Bob gave her, which is known as the redeemer value. And the output of this transaction would be that Mary will receive the ADA in a different address that's associated over her wallet. Because remember, in the UTXO format, we can't just add Cardano into an existing address. It has to be a completely separate address that is tied to our wallet. Taking a step further into the details, every Plutus smart contract has the concept of an on-chain code and off-chain code. On a very high level, off-chain code is the code that you write that would send the transaction to the on-chain code, which is the code that's located on the Cardano node. And the on-chain code, or also known as our validator script, is what uses the datum and redeemer to figure out if the Cardano should be released or not. Now that we understand a bit more about the Plutus framework, let's talk about what we want to build. So in this video and what I want to build up to eventually, I want to build a stock value guessing game. So for example, a person will guess if a stock like, let's say, Tesla is higher or lower in 30 minutes. And if they're right, they will get the money. And if they're not, someone else will get their money. But we won't have that implementation in this video. We'll go for a simpler one. So in our implementation, we're going to have two persons. Person A, they will lock up the ADA that they want to bid, and we'll also send in the current stock value. Person B will try to guess if the stock price is higher or lower, and then we're going to just hard code what the current stock value is. If person B guesses correctly, they will get the money. Otherwise, the ADA will just be locked in the contract. Now, to break apart the problem, we'll need to talk about the on-chain implementation and the off-chain implementation. So in the on-chain code, we need to create a datum and a redeemer. The datum will be what person A will send to lock the ADA. So what we need is the stock price and the Cardano that's being locked up. Now in this case, the Cardano value is already part of the contract, so we don't need to worry about that. So all we really need to store is the stock value. And then for a redeemer or a guess redeemer, we need to have a Boolean to represent if the stock price is higher or lower. We'll just say higher is true and lower is false. If the redeemer is correct, they get their money. Otherwise, the money stays in the contract. Now, I know there's a lot of edge cases. How can we automate the system? Couldn't Bob just lie and rig the whole entire game? How does Bob get his money back? And lots of other edge cases. I'm sure there are multiple ways to implement this. There are a lot of things I want to explore in the near future. But for now in this video, we're just here to create a simple datum and redeemer script and build a foundation. So now that we defined our on-chain code or our validator script specifically, we need to figure out what our off-chain code is. So the off-chain code is the interface that a user interacts with that creates and sends a transaction to our on-chain code. Users usually need to provide specific parameters to these endpoints, which then will be used to create said transactions. So how many endpoints do we really need in this script? Well, two. There's the person who's locking the value in their ADA, and then there's also the person that's trying to guess if the stock is higher or lower. So what sort of data do we need to provide these endpoints? Well, for the locking case, we need two information: the ADA the person wants to bet, and the current stock value. And for the guessing endpoint, we only need to include one thing: the guess, which is a Boolean. True represents that it's higher, false representing it's lower. Now, it usually varies on a smart contract by smart contract basis, but the endpoints and the params you pass it usually mirrors the datum and redeemer, and you're really just passing the data along. But of course, these are just very beginner scripts. I'm sure as the use case becomes more complex, so does the data that we send across the network. But this is roughly the spec that we want to use to create the smart contract in this video. All right, now that we defined the smart contract we want to implement, let's get started. One thing I want to point out, in my previous video, we set up WSL to be able to deploy the Plutus playground. And the reason that was done was because the original Plutus playground was not up to date. Well, it turns out now it is. So the official Plutus playground is now 100% up to date, and we no longer have to actually set up a WSL instance. Now, of course, it'll probably still be necessary because later on we do want to try and write more complicated scripts that won't be able to fit in the Plutus playground. But until then, we can just work directly off of the official website now. So now with that out of the way, let's implement our smart contract. I don't want to get into the theoretical and talk about what each line of code does. If you want to do that, I recommend looking through the Plutus Pioneer program. In these videos, I just want to do something quick and dirty and learn by doing and less by understanding some of the fundamentals. So we're going to repurpose the game script to make it into our guessing script. So the first thing we do is we need to define our datum and redeemer. So that's what these are. It's called hashstring and clearstring. We're creating a new object called hashstring and clearstring, which will be used as the datum and redeemer, which you can see down here. So let's say our hashstring will be our locked datum. Instead of the object representing a string, it actually represents an integer, which is the stock value that we're currently at. Now for our redeemer, we create our guess redeemer. And the guess redeemer is essentially just a Boolean. And that's how we define our datum and redeemer. It's pretty straightforward when you don't question and ask what the rest of the code does, which is a whole conversation that we're not getting into. So now that we define our datum and redeemer, we should use it in all the script locations that require it. So these are such as our script validator instance. This is all template Haskell that creates the smart contract. We're not going to get into details of it, but in all smart contracts, these are essentially the same copy and paste. So that's exactly what we're going to do. So our datum type is lock datum, and redeemer is guess redeemer. And we just copy and paste where appropriate. And we don't really need these helper functions. And the interesting part is right here, we have validate guess. This is our validator script where we decide whether or not we should unlock the funds or not. So the order, as you can see in the comment, is always datum, redeemer, script context, which we'll explore in a future video, and a Boolean, which represents whether or not we should release the funds. Oops, lock datum is, there we go. So our datum is lock datum, and our redeemer is guess redeemer. And then to define the type, we just grab the lock datum, and then we just grab the value, which we'll just call stock. And then to represent the redeemer, we have the guess redeemer type, and we call the param, we give it the guess. And then the underscore here just means that we're not using this variable. So now that we have a datum and redeemer, how do we know if we should unlock the funds or not? Well, we have the stock value, which is over here. If you remember, if you look at our lock datum, that's an integer. So what we say is if our stock value is greater than the current value, that would return true. If the guess from our redeemer is true, that means we're guessing that the stock value is higher. So what we're doing here is saying return true if our stock is greater than current. And if that Boolean is true and our guess is also true because the user is guessing that the value is higher, then we will unlock the funds. Now, if the user guesses false, then the fund does not get released. And likewise, if the stock value is actually lower than the current value and the user guesses it's higher, then the fund's also not released. And so that's a very basic implementation of a validator script. Remember, none of our code actually uses it yet. This is all the on-chain part. We still need to implement the off-chain part, which will make the transactions to call this. And we'll get to that shortly. But first, we need to define what current is. So if you follow along in the Plutus Pioneer program, there is a concept of an oracle, which allows us to get external values. However, in this instance, that's way beyond the scope of this video, so we're just going to hard code what the current value is. So we'll just write a small function that will just return something. So we'll say current integer. So write a current function that returns an integer, and we'll just say it is 1000. The price that I hope Tesla will be in a month or so. So now we're just comparing our stock integer that we get, and then we call the current function, which returns 1000. And so this is all we need to do to create a validator script and the on-chain code. So let's get started on off-chain code. This function is also not needed. Like we talked about in the off-chain code, we need to define the endpoints and the params that we need to pass it. So if we go all the way down at the bottom of this, we can see that our endpoints are defined right here in the endpoints function. And the endpoint function returns a contract, and that contract is defined from this function called game. So we scroll back up, we see that we have a function called game that calls selectless, which is something we don't know, but let's not worry about it. And inside selectless, we have two functions called lock and guess, and these are our endpoint definitions. So if we look at lock, we'll see a endpoint for lock, and if we look at guess, we'll see an endpoint for guess. Now, once again, I'm not going to go deep into the syntax of this, but this is how we extract the value that we set in our lock and guess param. Of course, we still need to update this to fit our smart contract implementation. So if we look at our lock params, remember the two things that we need to lock up. The first thing is a integer value, the stock value. And that is a integer, not a string. And then finally, we have the ADA amount that we want to lock up. That is already locally implemented for us. And in Pascal, the cardano value is represented as a value object. And so we'll just keep this the same, and luckily we can just keep the param name the same too, actually. And same thing for the guess param. So for the guess param, we have our guess, it's called guess. And instead of returning a string, we'll just return a Boolean. So now, whenever a user selects a specific endpoint, that endpoint, for example, lock, that lock endpoint will ask for the lock params, and I'll show you the UI for it later. And then when the user makes the request, we will do something with our implementation. So let's go through the lock case first. Because we changed the variable name of lock params, we need to update it. So instead of secret, it's stock, and instead of AMT, we'll call it amount. But technically, I don't think we need to actually change the name. So when the user calls the lock endpoint, we extract these values out. What this code does is it gets the endpoint, and then the value inside a lock param is changed into this anonymous function, which we extract out the stock value that the user is locking and the amount of ADA that they want to lock up. And then we enter this do function, and we can ignore the first line, 82, that's just a print statement. And then on line 83, this is where we create our first transaction. Plutus provides us helper functions that will create transactions for us to submit. There's a couple that we'll explore in future videos, but this is what must pay to the script does. It takes in the datum and the amount that we want to lock up. So we need to implement the datum first. The datum would be lock datum, and then the only value that we're passing it is our stock value. So this would be one parameter that we're passing into the script, and then our second parameter is the amount that we're locking up, which is just amount, and this would create a transaction for us to submit. Now, after we create a transaction, submit it by calling another helper function Plutus made called submit transaction constraints, and that takes in two things: the reference to the smart contract and the transactions that we have created. And that's it. This will submit our transaction and we'll start our smart contract. Now, let's look at the guess endpoint. If the user selects the guess endpoint, they would have to provide the guess params. Over here, we create an anonymous function with the value from the params, and then we extract out the guess, which is a boolean, true if it's higher, false if it's lower. Now comes the trickier part. So line 90 is another print statement. What's very typical for a redeemer action is you need to get the UTXOs, the unredeemed addresses in your smart contract that you want to try and redeem. Plutus once again provides another helper function to help you find all the transactions that you can try and grab. In this instance, there's only one, but it's also possible to have multiple. So all this function does is it takes in two parameters, the smart contract address, which is implemented for us over here. It's mostly just copy and paste, so I'm not even going to explore it. We get the address, and then we also create a constraint to return any UTXOs that has a Lovelace value of at least 1. So this would return us a list of all of our UTXOs. Alright, so next, and just like the lock param, we need to create a transaction to send to the validator script to redeem our ADA. So in this code, we create a Reedemer variable, which is our Reedemer. We're just going to adapt this, and we'll just create a Reedemer object, which is guess Reedemer, and then we just give it the guess value, which we'll still call it the guess, and this would create a guess Reedemer object. We have a Reedemer now, and now we just need to create a transaction to collect all the ADA with our Reedemer. So once again, we have another helper script called collect from script. It takes in the list of UTXOs, and then we give it the Reedemer value. This would create a transaction that would collect all the ADA from our unspent output. And then finally, once we have our transaction, we just need to submit it. So in the case of us trying to redeem ADA, we need to call submit transaction contain spending. Once again, it's just something you copy and paste. We give it the address of our script, which is our game instance. We give it the list of UTXOs that we want to try and redeem, and then we give it the transactions. I know this might be a lot to take in, but on the very high level, in all the endpoints we have, all we're really trying to do is we're trying to create the transaction while giving it either the datum or the Reedemer, and then we submit it to the onchain code. Now let's compile and see if this is correct. Yes, it's equals, not double colon, and let's try that again. So instead of calling the params guess, we'll just call it the guess, and that should handle that. Okay, and then we have a lot of leftover code. So we just remove all of the existing helper functions that are no longer being used. And then hopefully one more time. All right, we didn't rename the amount that we used. So more logging functions that we don't really need. And then there we go. We have our first smart contract. Now we'll go through this very quickly. So if we go to simulate, you'll see that we have our guess and our lock function that we defined. This is the front end that the user would talk to our off-chain code. We have two wallets, wallet 1, wallet 2. So the first thing we need to do is we need to lock up our ADA. So let's say the current stock value is 600, and we want to give 500,000 ADA. We need to wait a bit, and then let's say wallet 2 wants to redeem it, so they guess. And let's say they guess correctly and say it is lower, so we don't change anything. And we wait again, and then we evaluate. All right, so now we have our transaction complete. If we scroll down, we can see the final balances. 500,000 ADA is actually too small, but you can see right here that we locked up 500,000 and we redeemed 500,000. And we can also look through the blockchain and transactions to kind of see what we talked about earlier. So in slot 0, transaction 0, we just created our wallets. And slot 1, transaction 0, this is where we sent our lock param. So in this transaction, we only have one input, which is from our wallet, and the transaction would create 3 outputs. The fee that we have to pay, the new wallet 1 address, which has the total value after we spent the 50,000. And then of course our smart contract, which has 500,000 ADA locked in, along with our datum of 600, I believe is what we used. In our second transaction where we try to redeem it, our input is our smart contract that we made along with the datum. We create the transaction with the Reedemer, the validator script, but check to see if the guess was correct. And in this instance, the guess was correct. So they pay the fee of 35.44 ADA, and then they also redeem the 500,000 that was locked up, which is what we saw below. And this on a high level is all we need to do to create a smart contract. Of course, we're only touching the tip of the iceberg in terms of what we can do, but I hope this gives you an idea of how to get started. I hope you found these videos helpful. If you want to see more code example of actual practical implementation, please like and subscribe so you'll be notified of my next video. Otherwise, happy coding and have a great day.